Hey there! This podcast is brought to you by datacreators.club. It's a website I made to discover the best data content creators out there, no matter their channel, YouTube, Medium, Twitter, you name it. So go check it out and enjoy the show.
What's up, data folks? My name is Medio, and welcome to the Data Creators Club podcast, where we interview data folks from the fields and learn from them. Today we have an interesting guest, Mario. Mario is a senior DevOps engineer at Vokpak. And I wanted to have him on the show because he reacted on one of my LinkedIn posts saying that he didn't work with mainstream data tools, but he has a crazy interesting project that involves a lot of data. So we'll get back to that. Welcome, Mario, and thank you for being on the show.
Hi, thank you for having me.
Could you introduce yourself and just understand where are you from and what's your career path so far?
Mm-hmm. So as I told, my name is Mario. I'm from Portugal. I'm currently living in the Netherlands. And for my career path, I started as on the cloud part immediately when I come out of university. So I'm more part of DevOps infrastructure part. When I say cloud, is everything that is related to cloud. So from that infrastructure, databases, S3 buckets, whatever you mean, CI/CD pipelines, building the data pipelines. Majority of my career part was coming from startups, and now I'm working in the oldest Dutch company in the world. It's a 508 years old company. It's a company that is going through a digital transformation program. The company, as it was, is Vokpak. They store vital products. So everything that is in liquid state, it's the leading independent storage company, by the way, in the world. And we, besides storing liquid state, we store a lot of data.
Nice. So I understand that you work in a IoT environment. Could you high level the technology components involved in such a setup?
Mm-hmm. Our technology, we are using cloud services, okay? But these cloud services are running in the edge, okay? For example, we use AWS IoT Greengrass. AWS IoT Greengrass allows you to run AWS Lambdas at the edge, so on site, on premises. Then we use AWS Kinesis for streaming. We use AWS Batch. We use AWS S3 bucket. We use Glue and Glue Jobs, of course. And we use MongoDB for storage too, Atlas and locally too.
So the component involved on the edge is basically just the AWS Lambda. Am I correct?
No, at the edge, it's AWS IoT.
Yeah.
The AWS IoT extends, the Greengrass in this case, extends the AWS services. Okay. So I can use Stream Manager, which is Kinesis, at the edge. I can use AWS Lambdas. I can use Secret Manager. I can use the capability to deploy Docker images. So I run Docker images at the edge. Imagine having a Kubernetes cluster. You have your code, your Golang, your Node.js, your Python, whatever you want. You're running at the edge, okay, on site. So all those logging, for example, CloudWatch services for monitoring and logging, all these capabilities that the cloud offers as a service, you run it at the edge on site.
What's the sizing of the machine on site? It's still pretty light, right? Then, because you try to, can you give us a bit more information on that?
Correct. For more context on what we do, we process a lot of data before even going to the specs of the machines, okay? And currently, as I'm speaking, I'm looking at my dashboard. We are processing 65 million events per day. So when I say events, it's when the sensor detects a new temperature or a new level, okay? So, and it's like an event-based streaming platform, okay? So what happens, this is, yes, a very light machine. You can run it in a Raspberry Pi. It's like 1 gigabyte of RAM, We have more storage because we can queue messages and we can cache messages. So we have like 500 megabytes of memory, something like that, and a very weak CPU. Huh? So on a server, you can run this on the Raspberry Pi. If you have an Amazon Alexa at home, you probably are running Greengrass.
Okay.
That's why Alexa skills are lambdas.
Nice. What's the main difference and similarities, according to you, between a standard data platform and the IoT data platform? Like we just discussed, like, is it like just the collection on site, like what's happening on the edge, or is there like also other major difference you would see?
Yeah, so the difference running a data platform, so on a tech startup or tech company, you ingest data from your CRM, ERP, multiple sources, you transform the data and then you store, or you do ATL or AELT, right? And you put in your data warehouse. In IoT platform, everything runs at the edge and as much as possible detached offline. So, for example, I do at the edge the ingestion, the transformation of the data. I do temporary storage of the data. And then you can run complex event processing. For example, if this event happens, this event should be triggered. You can run, we are already prototyping, machine learning at the edge. So you train your data models in the cloud, and then you push to the edge. So it's called machine learning inference. Okay.
But so then, therefore, as I heard, with like caching temporary the data, you have a whole network disaster strategy plan, right? That you need to take into account, which is not happening, right? When you have all your stack in the cloud, right? Is that correct?
Yeah, correct. Yeah, you need to think about disaster recovery, to additional context to everything. It's because of our scale, huh? We have everything automated as much as possible and test as possible. Okay, our deployment is automated, our testing is automated. We have multiple type of testings. Every day, for example, we destroy a terminal and rebuild in order to test how much time it takes, how much time. So there is multiple failover strategies and disaster strategies for us.
Okay. So that's like we cover a bit the difference, like, and what are the similarities, like at the end, because as I heard, like at a certain point you have an S3 buckets, you give proper data to consumer, to analyst, or so like, is there like a cloud data warehouse over there, or like this end user stack, is it similar on your stack?
There's still a data warehouse. So what happened is there is still Snowflake in house. Huh? We have Snowflake in house, and we have other storage data integration tools like Informatica, Matilon. We have still a data engineering team. Huh? We are a part of a team that builds these type of components. Okay. Here we transform, so we ingest, we transform the data, and we then we send to the cloud, and in the cloud we have then Kinesis that streams to an S3 bucket of BI team, okay, which then has a dashboard that quickly sense and tableaus, whatever you use in your organization. And then we have an AWS batch, which batch the data to another S3 bucket, and then on this S3 bucket we have a data team that pipes the data to Snowflake.
Yeah.
Okay. So if you look at these, we kind of build on an architectural level, data architectural level. It's a Kappa architecture sometimes, it's a Lambda architecture sometimes. It really depends of the use case.
Of the use case.
So for storaging, we have S3, you have MongoDB. So because I didn't explain, we have a MongoDB cluster.
Okay.
We store the data. We have an AWS Lambda in the cloud that stores all the data in the MongoDB, in the cluster of MongoDB Atlas. And then we have an API, a Node.js API, running in Fargate,
okay,
which is a serverless container orchestration from Amazon.
Yeah.
that exposes the data to. So we have three options to expose data.
Okay, it's through the MongoDB or
bucket.
Yeah. Okay.
Yes, through an API. So we, for example, CRMs, ERPs can still the customer can fetch the data through an API. And then we have S3 buckets for the BI team or data science team.
Okay. Yeah. So that's really interesting. That also talked to me. Like I used to basically take data from different source and provide it as a different flavor, as I call them. So like an OLTP database, an OSQL database, as you mentioned, MongoDB, and then you have the object storage for different use case. Okay, no, that makes perfectly sense. So your job title is DevOps, but as we heard, you deal a lot with data. So do you consider yourself a bit of a data engineer or not at all? And how do you see like those difference in your day-to-day job?
Okay, this is the most software engineering reply. It depends. It depends of the day and the user story that I'm working. We do, for example, today I was doing infrastructure as code, CDK. Yesterday I was building some new routes in our API. And probably tomorrow I already have ideas to build a new data pipeline for alarms and events for a new location. So it's really difficult to measure workload.
When I heard like the components that you're involved, there is a lot of basically skills that you have to solve problem. That's what I want to highlight, and where I think today people focus too much on the mainstream tooling. Like, I want to learn Airflow, I want to learn Spark. Because it's needed, because everybody asks it, but what problem are you solving by learning those, right? That's where I think,
like using DBT, right? It's like using DBT. Everyone is using DBT now. Everyone is using Fivetran. Everyone is using Snowflake. It's not necessary. What you need to learn is understand first your customer or your company. And the problem that you are trying to solve, what is the best tool to solve the problem? Because, for example, in our case, you go just with Docker containers, deploy everything with the Docker containers, use Python and Golang, put everything in SQL, use Kafka at the edge. But I don't have the resources, the infrastructure, the knowledge in-house, the funding for playing with that tools, because I need to deliver fast.
Coming back just on the technology itself, because I found it really fun to play. So IoT Greengrass from AWS, you said like it's run on a Raspberry Pi. Would you recommend it for a side project? If yes, do you have any idea for people like getting into those things?
Yes. Bear in mind, it still have costs. It's like $1 a month, $2 a month. It depends how much Lambdas you run, but there is still costs associated with it. Want you guys to go bankrupt because of me?
No, but the cost is like, for a side project, if it's $1 per device and you have one or two, let's say I have $5 to $10 budget a month for a side project. Can I build something?
Okay, for example, yes. For example, I have a lot of Raspberry Pis. I was trying to see. I have, my house is full of Raspberry Pis. My wife sometimes is like, another one? And for example, I'm using a Raspberry Pi and IoT Greengrass and all the tools like QuickSight for visualization, Grafana as a service from Amazon for visualization to monitor my energy consumption and production. I'm connecting directly to my solar panels distributed and my energy meter. And I have a smart temperature meter, and I can see I have then on outside thing that measures the outside temperature. So I'm measuring all these values to see when I'm wasting more energy, consuming more gas, not so gas. I have a fishbowl, and I have a probe, and I have the monitoring the quality of the water and the salt level and all that things.
I think there is a lot of things to play at home, and the components are pretty cheap actually. And it's you just need to think of the use case, and it can serve you well directly at home. Cool.
Yeah.
So what's the next major thing to be done in the IoT environment? Where do you think it's heading?
It's the machine learning part. Okay, so you need the data. As soon as you have the data and good data and a lot of data, you can run then machine learning at the edge. I think the capability, for example, in China, I know China is using image recognition at the edge a lot. But even if you apply this to factories, or like if a pump is going to get broken, can predict that, or even like for safety. Imagine a construction. You're in a construction, and you can use that camera information to detect if a person has a helmet or not.
And this is today a bit done, but really like with some company that has like proprietary products, right? They do everything. I feel like if you have like, I know like for example, camera that detects plate from car. They have their company, and they provide everything. They provide the camera, the software. But maybe we're going to see that decoupled over the years coming. Like, you can pick your own hardware and your own software.
The problem of these companies or the IT field in this case, in our case, industrial IoT field, it's more industrial manufacturing, is the fragmentation.
Yeah.
So you have a lot of companies. And for example, for our case, they need to be ATEX certified. So because of explosion, they can explode. Because of oil and gas, it's dangerous. So they need specific certifications. And most of them, they don't have it, or they are working for it. But then when you go to these ATEX certification companies, or they are not good at ingesting, or they're only good at edge part, or they're only good at machine learning. So it's very fragmented. They don't offer like when they offer one solution with all the things, it's very expensive.
Yeah.
Or it's hard to maintain.
Yeah.
Or
and difficult to extend or collaborate with other components, I guess.
Yeah. So if you have one small factory, if you are an industrial company or you are at home, you maybe can get this project off of the shelf easily, and you plug and play, and it's done. But if you want these at scale, let's say smart cities, right? Right now it's the new fancy words, or digital twin cities. At scale, if you are like a country trying to implement it, it's hard to do it. You know, you will need to hire like 10,000 people, 15,000 people to maintain it.
No, that's good times ahead. Hopefully, more open. That's nice. So, closing up the talk with you. What are you looking for in the future as engineer? What makes you excited?
Currently, for example, right now I just posted on my LinkedIn some results. I'm working on machine learning to data contextualization. So what happens is with sensors in the industrial sector, when we ingest the raw data, it's like the sensor gives like a sensor ID, which is like 0033.CV 87. You don't know what is measuring, what is the unit of measurement, which type of sensor it is. The unit of measurement they already told, but the type of measurement, which type of sensor it is, what is the meaning, the context of that data. When you do the transformation, you add that context, right, to the sensor, which information it is. But you need to get this information. Currently, it needs to be the engineer on site that needs to provide you this data. Needs to tell you, this is this type of sensor that will do this type of context, this type of measurement, because it could you type of measurement. For example, you can measure if the cup, a cup is empty, half empty or half full, right? In-ledge or ullage in this case. So I'm using the machine learning with the data that I already have. The other thing that I'm looking is for data quality and retrofits of the data. If you change the schema at our scale, right? If I change I have a data migration. If I change the schema in one location, I need to change in the cluster with 8 terabytes, with 8 billion records, right? So it's at scale. How can I change this? If a new terminal comes and say I want this payload different, I want to change this on the payload instead of a string. I want to be, I don't know.
Yeah, don't change type on an existing schema. It's painful, right?
Yeah. What I'm saying is that so there are two things, three things in this case: data quality monitoring, data migration in this case, and the machine learning part.
It's very interesting that like now you've been collecting data, so you basically feed that data into a model to make like your process smoother and smarter, right? Thank you for being with us, and have a great day.